Sonic, the heart of your system.
What is up, guys? This is Luke Hill for Kiku, and this is the ASUS ROG Strix TRX40E gaming motherboard. So this is a £500 roughly STRX4 offering for the new Threadripper 3000 chips. So at just under £500, this is one of the more affordable STRX4 motherboards because there's quite a lot of competition in that £400 to £500 price point. So notably, there's gaming in the name, but this isn't for gamers, let's be perfectly honest. The TRX40 platform isn't for gamers. This is for enthusiasts who want a bit more than what an entry-level STRX4 motherboard offers them. So how will it stack up to the competition in this pretty tough segment of the market? Let's find out. The first thing we'll notice about the ASUS ROG Strix TRX40E gaming is that it's an ROG Strix product and it looks like other ROG Strix products. So you've got dark black PCB, you've got black slots and black connectors. I personally think it's a very good looking motherboard. I like the Strix styling. And then for color contrast, ASUS relies upon the RGB zones specifically. So you can make a neutral color scheme or you can tailor it to your needs. Very good looking board in my opinion. As is the norm for premium motherboards in today's market, we get the integrated I/O shield on the back, which you'd expect at this price point, and then you get a rear I/O cover. In this case, it's plastic and it features some additional branding that we'll get onto. So 3 distinct lighting zones are available on the TRX40E gaming. You've got the chipset heatsink, so some RGB lighting on the chipset heatsink, some RGB lighting on the VRM heatsink, and then some RGB lighting on this rear I/O shroud. And this is like a piece of acrylic which has got the ROG and Strix branding etched into it, so that looks pretty cool to be fair, and the other two are pretty good. The chipset heatsink, once you install a thick graphics card, you can't really see it because the lighting is quite high up on the heatsink, so it's kind of pointless, but it is there, you know, if you're interested in that. Importantly, it has this Live-Oled Display, and this is actually quite functional because during post, this tells you what is going on with your system, so whether it's booting through memory, whether it's dealing with the VGA, so it gives you useful information. It's not just a gimmick, and it is a pretty cool upgrade from this typical 2-digit debug LED that we'd see. So I like that feature. Functional, pretty cool too. Given the TRX40 platform's quad channel memory capability, we get, unsurprisingly, 8 DIMM slots. So you can put up to 256 gigabytes of non-ECC memory in here using the highest currently available 32 gigabyte DIMMs. Now officially Threadripper supports up to 3200 megahertz, depending on which memory configuration you're going for. Obviously 3600 is a sweet spot, but ASUS does highlight support for over 4600 megahertz kits according to the QVL, so that's pretty cool to see. These are obviously single latch connectors, and ASUS rotates the latches on different points just so it's a bit easier to not interfere with this large VRM heatsink above. And notably, ASUS actually has a QVL for ECC memory support. So if you want to run ECC, you can look at that QVL and you can possibly run it. So that's a pretty cool feature to have. Close to the right side DIMM banks in the usual position, we'll find obviously the 24-pin connector. And then here you get the internal USB 3.2 Gen 2 Type-C header. You get 2 RGB headers, one of which is addressable. These are in a good location for roof-mounted or front-mounted RGB fans or kits, so good to see that. And then importantly, you get this vertical M.2 connector. So this is one of the 3 M.2 connectors on the board. And this vertical orientation is good because it's in a region where you can quickly install a brand new SSD without fussing about if your system's already built. It's very easy to access. Now, this supports PCIe Gen 4x4, obviously up to, and SATA 60 gigabits per second SSDs because it's driven by the TRX40 chipset. And I like this vertical orientation because you can install long drives up to 110 millimeters in length. And because it's vertical, it doesn't really need a heatsink because in a typical case orientation, you'll get front airflow direct from the front fans here, so cooling shouldn't be a problem. I like this. Smart move by ASUS. Switching around to the top edge of the motherboard, we get obviously the dual 8-pin connectors. Now dual 8-pin is smart for Threadripper. Out of the box, the Threadripper 3000 CPUs will draw 285 watts from the package. If you overclock, you're well over 400 watts comfortably. So dual 8-pin's smart. And I actually like the way that ASUS splits these. So it might make your cable management a bit easier. Depending on your case, it might actually make it a bit more difficult. But you're injecting power at either side of the large and long VRM systems, so there could be some benefits there. Also in this top edge are two 4-pin CPU fan headers, and these are obviously CPU and CPU optional fan headers, but there's only two, and that's a bit disappointing. There should have been a third header here for the AIO pump header that we typically see, because the next nearest header is about halfway down the motherboard. So if you've got a roof-mounted AIO, which is very common, you can run your two fan headers in there, and then you're going to have to trail a cable along the board. Coming around to the SATA area, obviously we've got 8 SATA 6 gigabits per second ports, and these all run from the TRX40 chipset. The good thing is that none of the devices, so SATA or M.2, share bandwidth with each other, so you can use all of them at any one time, which is ideal for storage nuts. Alongside the SATA ports are one of the two internal USB 3.0, if you prefer USB 3.1 Gen 1, so 5 gigabits per second headers. This is in a right angle orientation, which could be quite convenient for cable management, but obviously you've got the vertical mounted one down the bottom if that's a problem. This actually runs from the chipset, but through ASMedia ASM1074 hub. So that hub takes one USB 3 connection of 5 gigabits per second and multiplies it out to 4 physical ports. So if you are shifting a lot of data from front panel USB connected SSDs, you might want to move some of those SSDs to the rear ports, which are more plentiful when it comes to bandwidth. Looking along the bottom edge, in the bottom right we've got the onboard power connector. Great, love to see this on a motherboard of this caliber, ideal for troubleshooting. It's kind of very inconspicuous, but it's there, so that's fine. Moving along then, we've got the other internal USB 3 header. We've got two USB 2 headers, and this is good to see too for RGB controllers or AIO controllers, for example. Two still ideal. We've got two more RGB headers, one of which is addressable. And then we've got the ASUS node connector for system monitoring. And then we've got 3 4-pin fan headers rounding out the bottom panel. And these are located quite well for front panel fans, for lower mounted fans, and for a water pump, for example. One thing to note is that there's no internal Thunderbolt 3 add-in card connector, so that could be a bit of a problem for some people. The primary pair of M.2 connectors, which are driven by the CPU specifically, are found beneath this slab of metal underneath the primary PCIe full-length slot. Now, according to ASUS, this large slab of metal is as good as individually cooled SSDs, even when you've got 2 SSDs beneath there. But when you've got just one SSD installed, then the cooling benefits are better compared to a smaller individual heatsink on competing solutions, according to ASUS. And that seems pretty reasonable. It's a big slab of metal, it's got thermal pads on it. It does a pretty good job. However, the fact that it's a big slab of metal and the position with regards to an open air graphics card, which are most graphics cards these days, mean that you're going to dump a lot of hot air straight onto this cooling plate, and because it's bigger, it's going to interact with more of that exhaust air from the graphics card. So you might see temperatures that are higher than you would expect for low load situations on your SSD. But to counteract that, ASUS actually directs some of the airflow from the chipset fan in a rotated pattern through to interact with the M.2 connectors. So pretty smart move there to overcome a problem with regards to positioning. Another problem with regards to positioning, in my opinion, is something that I don't really like, to be honest, is that this is mounted directly beneath a graphics card. So if you want to install or if you want to mess around with your SSD when the system's built, you're going to have to remove that graphics card. And that's pretty simple, unless you've got liquid cooling on the graphics card, and then it's an absolute nightmare task. So that vertical M.2 connector up in the top right becomes even more valuable. My advice would be to stick your first and second M.2 SSDs in here, leave them alone, don't touch them, and then if you want to add another SSD, use the vertical mounted one in the top right. When it comes to expansion slots, ASUS's TRX40E gaming motherboard is not ideal, to be perfectly honest. So you get 3 full-length steel reinforced safe slots, and these all run at by 16 bandwidth directly from the CPU because you've got plenty of lanes with Threadripper. You then get an additional PCIe Gen 4 by 4 slot that connects to the TRX40 chipset, and this is closed-ended, not open-ended, so you can install a maximum of a by 4 card in there. The reason I say that the slot layout is not ideal is because if you install a triple slot graphics card in the top slot and the other primary by 16 slot, then that's it, you can't install anything else. If you install dual slot graphics cards, then you're only left with either the PCIe by 4 or one of the full-length connectors remaining spare. If there was another connector above that secondary PCIe full-length connector, then for dual triple slot graphics cards, it wouldn't have made a difference. But for dual dual slot graphics cards, you'd be given an additional port that would be perfectly functional. So I think ASUS should have gone for that approach. And that's what we see many of the competing solutions at this price point doing. They are a bit smarter with the slot layout, especially for when you're installing lots of bandwidth heavy expansion cards, as you should be doing with Threadripper. I'd wager, based on the slot layout, that ASUS is gunning for single GPU users with this motherboard. So if you've got a 2.5 or a 3 slot graphics card, you still get access to the 3 lower slots for high bandwidth devices such as RAID controllers or high-speed NICs or capture cards, for example. It's just when you start using dual graphics card is when the slot layout starts to show its limitations. One thing I will say, however, is that even though there are some challenges with the slot layout on this motherboard, it is certainly better than ASUS increasing the size to XL80X, which gives you real headaches when it comes to chassis selection. And this is actually an ATX board, so it's not E80X either, so that even further widens your chassis choice, so that's a good thing. The audio solution is based around the Supreme FX system, according to ASUS, and this is basically using the Supreme FX S1220 audio codec. So like other vendors for Threadripper motherboards, ASUS has to use a Realtek 4050 chipset to be able to take the USB port and convert that into an audio port. This is because the Threadripper platform doesn't natively have HD audio support. In addition to the Supreme FX codec under there, we've got Nichicon audio capacitors and a Texas Instruments R4580i operational amplifier. The rear I/O is about as heavy as it gets when it comes to USB ports. You've got a bank of older USB 2 ports, which are good for legacy devices, keyboard, mouse, printer, and also BIOS flashback duties. And then you have an even bigger bank of 10 gigabits per second USB 3.2 Gen 2 ports. And these come from either the TRX40 chipset or direct from the Threadripper 3000 CPU itself. You get one Type-C port at 10 gigabits per second, and this is obviously using an AS Media controller to make this Type-C possible. In addition to the USB ports, we've got Wi-Fi 6 capability through an Intel AX200 adapter, so it's up to 1.73 gigabits per second throughput, and this includes Bluetooth 5.0 support. The primary NIC is an Intel i211AT, so that's 1 gigabit per second, and then you get an additional NIC from a Realtek RTL8125 controller, which is 2.5 gigabits per second speed. Now, it's good to see that 2.5 gigabits NICs are being more widely adopted, but I'd say it's a bit disappointing on a motherboard of this caliber, especially when you look at the competing solutions, which are generally offering 5 gigabits per second or 10 gigabits per second. 2.5 gigabits is obviously faster than 1 gigabit, so that's good, but if you're going out to a storage server, 2.5 gigabits is pretty slow compared to 5 gigabits. If you've got a 5 gigabit NIC, you can realistically saturate a SATA SSD that's being used as a scratch-write SSD on a storage server. You can't do that with a 2.5 gigabit NIC. So that's a tangible difference for people who need to do a lot of network-connected work on their engineering projects or their video files, which is perfectly reasonable for the Threadripper platform. A bit disappointed to see ASUS cheaping out and only going for a 2.5 gigabit connector there. I would rather see 5 gigabit. And then obviously rounding out the rear I/O is the usual set of audio connectors, and then we've got the optical SPDIF connection. It's a little disappointing to see there's no clear CMOS button on the rear panel, because when you've built the system, it's very easy to access the clear CMOS on the rear panel, especially when you need to be doing BIOS updates and register updates for the relatively new Threadripper platform. When it comes to fan connectors, you get 7 4-pin fan headers distributed across the board, and the distribution is pretty good. So you get 3 within reach of the CPU socket, only 2 of those are allocated specifically to CPU duties, and then you get a few along the bottom edge. So I say that's pretty good. It's slightly disappointing to see that we don't get any onboard voltage monitoring checkpoints, because this is still an enthusiast platform after all, and people will be overclocking heavily and checking the system. So it would have been good to have some points to check that the data we're getting from software is accurate. For the 16-stage beastly power delivery solution, ASUS is using the ASP1405 DigiPlus controller. This is widely believed to be a rebadged International Rectifiers 35201, so a very high-end PWM controller, which features 8 lanes of capability. So obviously 16 does not equal 8, and ASUS doesn't use doublers, so this is a teamed 16-stage motherboard VRM solution. So you get 1 control phase from the PWM controller, manages 2 power delivery phases in parallel operation. And ASUS suggests that this gives you a latency benefit versus phase doublers, because you get a faster response time, but of course you get slightly reduced granularity compared to the higher number of phases provided by doublers also. We know that people don't like to call this a 16-phase solution because you've only got 8 control phases and it's teamed, but if you're comparing to other boards on the platform which are using doublers, this is more akin to a 16-phase solution than an 8-phase solution because you've got 16 total power delivery phases that are giving you the current capability to your CPU. The power stages used are 16 of Infineon's TDA 21462 60 amp power stages. So these are slightly derated versions of the 2147 70 amp power stages we've seen on some of the flagship boards. These are very high performance co-packaged solutions and they should be operating at a good efficiency level and a good current capability level even with the higher end overclocked Threadripper chips. So I personally would have no problems worrying about even putting the 64 core in an overclock configuration on this board. This is a very, very healthy VRM solution. And just as a note, the capacitors around the power delivery system are mil 5K rated, which seems a bit slim, but obviously because they're mil standard, they test them at a different temperature threshold, so they're probably comparable to 105 degrees Celsius 10K rated. They're perfectly fine, realistically. The VRM heatsink is a massive tiered hybrid type approach, and the reason I say it's a hybrid type approach is because number one, it makes direct contact with the 16 power stages and also the chokes. So the chokes are not necessary to cool, but it makes a bit of contact, so it's not really a bad thing. It's hybrid because it's primarily using a slab of metal for thermal capacitance, but then there are some fins there for more effective heat dissipation. So it seems like a pretty slick solution. When you then combine the fact that there are 2 30mm PWM controlled fans on there, then you can see that VRM cooling really shouldn't be a concern, especially when you factor in the efficiency of the Infineon power stages. Now the fans themselves are controllable in the UEFI, and by default ASUS sets them so that they don't kick in whatsoever up until a 60 degree Celsius VRM temperature. And based on our testing, as you'll see later in the review, that's actually quite difficult to reach. So these fans are basically silent for heavy loads unless you're overclocking quite heavily. And of course, if you want to set the temperature threshold higher before they kick in, or if you want to make them more aggressive, you can control that within the UEFI. So it's a really good feature. I mean, realistically, this is just a massive slab of metal with some fans on there, so cooling worries are not going to be a thing here, realistically. There's a metal strip with a thermal pad on the rear of the PCB, and this is directly beneath the power stages mounted on the front side. This doesn't actually make any direct contact with any logic because there's nothing on the back, there are no phase doublers, but what it does is soak some heat away from the PCB directly beneath the power stages. So that's perhaps somewhat useful. The chipset's cooled by a 40mm fan, and I like the mounting location of this fan because it's close enough to the bottom of the motherboard that it just gets away from the exhaust point of a graphics card installed up top, so it should be dealing with slightly cooler air than the hot exhaust air, so good move by ASUS there. This blows through a rather large fin array given it's a chipset, and that, as I've already mentioned, is directed so that some of the latent air then gets passed through to the M.2 heatsink nearby. So the open rotor design of the fan, the radial blower, means that ASUS doesn't really have to spin it particularly hard. We saw it stay below about 3,500 RPM in our testing, and it wasn't particularly intrusive at that point, to be honest. So if you want more details about this motherboard in written form, then make sure you head on over to the Kikaroo website, and while you're there you can also see some of our analysis for the UEFI of this board. We're going to now jump into the test system. Our TRX40 motherboard test system uses AMD's flagship Ryzen Threadripper 3970X CPU. This 32-core beast and its ample connectivity and 280-watt TDP should stress even the high-end motherboards on this platform. Memory comes in the form of a 4x8GB kit of 3200MHz C14 G.Skill Trident Z RGB DDR4. The Samsung B-die ICs under the hood still prove their worth, even though Zen 2 is a good match for more expensive 3600 C16 modules. CPU cooling is handled by the Cooler Master Threadripper. We specifically use this air cooler as it has a TR4 sized contact plate, and our own testing has shown that cooling Threadripper's large heat spreader can cause cooling challenges with smaller AIO cold plates. Pixel pushing power comes from Gigabyte's beastly Aorus RTX 2080 Ti Extreme graphics card. This triple slot monster pushes the GPU performance to a level where we can identify differences between competing solutions. We use a custom fan curve to minimize thermal throttling and ensure consistency between test configurations. Power is delivered by the new Seasonic Prime TX1000 80+ titanium rated PSU. This 1 kilowatt beast serves up clean power and a pair of 8-pin CPU connectors that are ideal for our overclocking stress tests. The latest BIOS at the time of testing is used. In this case, that is version 0602, which features the 1002 AGESA revision. On to the testing. As expected, performance between the competing boards is very similar in Cinebench. Gigabyte's price competitor pips the ASUS TRX40E gaming to top spot in the multi-core test, but the differences between all solutions here are unnoticeable in real-world usage. All-core frequency for the ASUS board was around 3850 to 3875 MHz during Cinebench loading. When accounting for numerical rounding, there's nothing to separate ASUS's and Gigabyte's £490 offerings in the Blender BMW test. That exact same point holds true for the classroom test. Clearly, ASUS's BIOS is delivering the level of performance that we'd expect from TRX40. ASUS's core frequency averaged 3825 MHz in both Blender tests. ASUS trails Gigabyte a little when it comes to memory bandwidth performance in the Ada test. The exact reverse is true for Cysoft Sandra numbers, with the lead switching to ASUS's option that delivers 62 GB per second with 3200 MHz CL14 DDR4. Latency is also an area where ASUS performs well with the TRX40E gaming. Despite the differences shown in these tests, there are no major causes for concern from the ASUS board's numbers. Similarities in boost clock behaviour means that performance in game-related benchmarks is similar for all options. ASUS's ROG Strix TRX40E gaming does pull out a small victory over its Gigabyte competitor in 3D Mark TimeSpy. However, the ASUS board is a few FPS slower on average in our Shadow of the Tomb Raider testing. Either way, you'll get good gaming performance from all solutions on offer here. M.2 performance is as good as we'd expect, with the PCIe Gen 4x4 slots having no problems feeding our almost 5 GB per second Aorus 2TB NVMe SSD. Cooling performance from ASUS heatsink was perfectly good, with our log showing a peak temperature of 63 degrees Celsius for the Crystal Disk Mark test run. That's a similar level to what we've seen from competing motherboards, so short, bursty SSD loading does not seem to be hampered by ASUS's cooling plate design. SATA performance was also right where we would expect it. Given the plentiful quantity of SATA lanes for the TRX40 platform, add-on chipsets are not used on the ASUS TRX40E gaming motherboard, so all SATA 6GB per second ports will run at full speed. Rightmark Audio Analyzer rates the ASUS ROG Strix TRX40E gaming motherboard's Supreme FX audio system as very good overall, with most of the categories actually scoring excellent. We were able to hit a stable frequency of 4100 MHz using a load voltage of 1.232 volts according to CPU-Z and HW-Info. This used a BIOS set core voltage of 1.25 volts and level 7 load line calibration. ASUS's load line calibration settings continue to make no sense and feature no useful explanation in the UEFI. Trial and error got us to level 7, which resulted in a steady state offset of 28 mV, which we deemed to be acceptable for our testing, stability checks and cooling hardware. Greater CPU frequency capability was achievable, and I'm confident that the motherboard could push further. However, going past this voltage level and clock speed requires cooling performance beyond a dual tower air cooler or even a reasonable 240mm AIO. At that point, you should be looking at a 360mm AIO with high-speed fans or, more realistically, custom liquid cooling. ASUS provides an excellent set of onboard monitoring data points, including temperature sensors for the CPU, VRM and chipset. The VRM temperature sensor is particularly good to see, as it should be at this price point and performance level, as users can tweak the VRM fan curve based on the temperature levels observed in their usage and their tolerance towards increased operating temperatures. A solid performance boost of just under 800 points or close to 5% was delivered by overclocking to a static 4.1 GHz. ASUS applies sensible voltages for stock operating conditions, and these resulted in reasonable power draw levels. Compared to Gigabyte's relevant competitor, the ASUS TRX40E gaming required a smidgen less power at idle and when loaded. Realistically though, there's little difference in the results here. Overclocking forced the system draw from the wall beyond 550 watts. ASUS's board was perfectly capable of feeding the hungry, overclocked CPU, and it did so with no motherboard-related stability concerns in our testing. Clearly, a strong power supply like the Seasonic Prime TX1000 unit that we used is an absolute requirement for a Threadripper system with a power-hungry graphics card thrown into the mix. ASUS deserves a lot of credit for the superb design of its VRM system. The use of 16 60-amp power stages results in strong operating efficiency for the electrical components, thus reducing their efficiency losses as heat. This, in turn, reduces the load on ASUS VRM heatsink and gives it a relatively simple job of keeping the components cooled. At stock, the VRM sensor never went above 59 degrees Celsius in our testing, with the Threadripper 3970X pulling at 285 watts. As 60 degrees Celsius wasn't reached, the VRM fans didn't kick in, and that's a positive. Overclocking pushed the VRM temperature past 60 degrees Celsius within 5 minutes of load being applied. At that point, the VRM fans kicked in and rotated at reasonable levels to keep the system adequately cooled without becoming noisy. Of course, the fan speed curve and spin-up temperature can be manually tweaked in the UEFI. Chipset cooling was perfectly fine. We saw temperatures around the 70 degrees Celsius mark after extended system operation. The 40mm fan tended to stay below 3500 RPM, so noise levels were tolerable and weren't particularly audible over a CPU cooler fan. Coming in at just below £500, this is one of the more affordable TRX40 motherboards, but it's kind of in that mid-range point because there's a lot of competition between £400 and £500. But we think this is a good option, to be fair. There are a lot of really good features that we like to see for Threadripper. You get a higher speed network controller, you get plenty of M.2 SSD connectivity, you get lots of SATA interface, you get good bandwidth through the USB controllers, and you get a superb cooling solution. So a lot of things to really like. When it comes to performance, we had absolutely no complaints whatsoever. The system held our 32-core 3970X stably, perfectly fine, and we were able to overclock pretty well, even with our limited cooling performance from the CPU cooler specifically. The thermal performance, as I've already alluded to, of the VRM heatsink is particularly good, and this is a combination of ASUS' choice of smart, efficient power delivery components and the hybrid, big slab if you prefer, block of metal that is used to cool the VRM. So that big slab of metal really does absorb a lot of heat, especially in the stock conditions, so that those 30mm fans don't really have to spin up unless you push them pretty hard. And even when you push them pretty hard, you can set them in the UEFI to spin up at a higher temperature that you're happy to deal with. So good solution there, a lot of control, and it doesn't really add any latent noise that you don't need, but it's got the cooling potential of the fans there if you really do need it. Very smart by ASUS, I like that a lot. Now I've pointed out that I like that there's a high-speed network controller included, but this is where some of the gripes start. I think at this price point it would have been reasonable to ask for a 5GB Ethernet controller like we see on many of the competing solutions, because 2.5GB is probably pretty slow for a lot of users on this platform who are dealing with storage servers on the network. I'm also not entirely impressed by the position of the M.2 connectors for the primary slots, but you know, this is very common on motherboards at this price point. It's a bit awkward, it's a necessary trade-off. At least you've got the vertical mounted one where you can access that very easily even when your system is fully built. And then I guess when we get to more of the geeky points, there's no voltage monitoring points and no clear CMOS button on the rear panel. They're a bit disappointing, but they're hardly deal breakers for day-to-day usage. It's just a bit disappointing for enthusiasts who do really like to tinker with this system quite regularly. Overall, with the slick design, which is a factor because people are enthusiasts, they like the look. I like this Live-Oled display because it's pretty cool, but it's also functional. And the overall feel of the motherboard is very, very premium, so I have absolutely no problems recommending this. Certainly not cheap at £500, but it's a pretty decent upgrade versus some of the lower cost motherboards, especially if you want some of the features that are offered here that aren't offered on some of the competing solutions. Pretty good board overall. Good job, ASUS. So I've been Luke Hill for Kicker. I hope you enjoyed this video. If you did like it, then give us a like and hit that subscribe button so you can keep up to date. If you want to see more details, then head on over to the Kicker website. That really helps us out. And if you want to support us, then you can check out our Patreon page, and also you can check out our merch store where you can buy some cool merch. See you next time.